The 60% data tax. Nvidia's Rubin R100 consumes 60% of its total energy budget, merely moving data between HBM4 stacks rather than performing a single arithmetic operation. While the press releases focus on the 50 petaflops of FP4 compute, the actual architecture reveals that the compute cores are often sitting idle, waiting for the memory controller to feed them. The transition to the Vera Rubin platform in mid-2026 is less about a raw speed increase and more about an engineering attempt to bypass the memory wall. With 288 gigabytes of HBM4, Nvidia is effectively tripling the bandwidth of the Blackwell generation to 22 terabytes per second. This shift suggests that the era of scaling by adding more floating point units has reached a point of diminishing returns. The real performance gains now come from how efficiently a chip can access its own state. The CMX Context Architecture. The Vera Rubin platform introduces a new hardware tier called CMX, or Context Memory Storage, which treats the inference history as a first-class system resource. Unlike previous architectures that treated the KV cache as a temporary byproduct, CMX uses BlueField-4 processors to manage million-token context windows across a unified memory pool. This allows agents to maintain persistent state across thousands of turns without the massive latency spikes typically seen during context reloading. The technical papers show that by offloading context management to a dedicated storage tier, Nvidia can maintain high GPU utilization even as models scale toward 3 trillion parameters. It is a fundamental pivot from calculating tokens to managing the history of those tokens. This persistence is what enables the multi-step reasoning required for the agentic workloads currently dominating the June 2026 deployment cycle. The Groq 3 LPX Pivot. In a quiet move 3 months ago, Nvidia canceled the Rubin CPX chip, which was originally slated to use cheaper GDDR7 memory for long context inference. Instead, they integrated the Groq 3 LPX technology following a $20 billion licensing deal to prioritize ultra-low latency SRAM. This change indicates that for agentic systems, the throughput of GDDR7 was simply too slow for real-time reasoning loops. While GDDR7 offered higher capacity at a lower price point, the overhead of moving data in and out of the GPU cores created a bottleneck that the newer SRAM-based architecture avoids. The hardware trade-off is clear. Nvidia is sacrificing the broad availability of cheaper inference chips to ensure that their flagship Rubin systems can handle the tight feedback loops of autonomous agents. This specific architecture move confirms that the bottleneck for 2026 is no longer model size, but rather the speed of the reasoning loop itself. The signal under the noise. The Vera Rubin era marks a definitive transition where the primary metric for supercomputing has shifted from floating point operations to memory bandwidth and context persistence. By prioritizing the CMX architecture and locking in 70% of the global HBM4 supply from SK Hynix, Nvidia is acknowledging that the bottleneck for agentic AI is the state, not the math. For builders and researchers, this means the focus moves away from optimizing model weights and toward managing the KV cache and long-term agentic memory. The hardware is no longer just a calculator, it is becoming a state management engine designed for always-on reasoning factories. The real implication is that model performance will now be gated by the physical ability to move context between GPUs rather than the number of parameters in the model. Watch the yield rates on HBM4 through the end of 2026 as the single most important indicator of whether this agentic shift can actually scale to production volumes. Subscribe for more.